So regular practice, daily we have to take just 1 minute is a normal breath. Just take the breath. Inhale through the left and exhale through the right. It's a 4-time inhale, 8-time exhale. Slowly, same repeated for 1 minute. First, this is a first step. Second step, you have to write it a affirmation. I will show it affirmation. Then we will start with the classes. This is a simple process. You have to keep it your mind calm, everything calmly. Then you have to change your identity. Then we will start learning. Then it is very easy for me. Connect with you. Clear? Okay.
Yes, sir. Clear.
Okay. Just start. Relax process. This is 1 minute only. You can do 3 times. 3 rounds. Left, right, left, right, left, right. Like this. Okay, relax. Now we will share the PDF. Just write it this affirmation quickly. Vijay Panjal, can you share that your identity, that statement? Can you see that screen?
Yes, sir.
Okay, any free time, you have to write and share it our group. Okay?
Okay, sir. Fine.
Okay, you can write it. This affirmation quickly, 30 seconds.
I'm confident that capable and will great and going take action by speak forward.
Okay, just unmute and pronounce this sentence loudly.
I'm a confident
Yes, I am a confident and capable energy auditor, energy manager. Every day I grow in knowledge, take action and make a difference in the world. And I am committed to sustainability, success and creating a better future. You have to loud, you can speak. Just unmute and speak.
Affirmation: I'm a confident and capable energy leader or auditor. Every day I grow in knowledge, take action, and make a difference in the world. I'm committed to sustainability, success, and creating a better future.
Okay. Okay, Modak. Okay, Rajesh. Okay. Today we are going to start with chapter 6, pumping and pumping system.
Yes.
Okay. In your home, you have the pump now?
Yes, sir. We have water pump.
Yeah, we have pump, but this is a different concept. Is a from your, we are taking from basic only. This is a tank, underground tank. This is a water tank. This is your tank. Okay. What are the possibility we can shift the water to here? From this tank to 1 to 2. 1 to 2. What are the possibility?
Without external force, there is a zero possibility, sir.
Yes, manpower, you have to take your bucket and take it and fill it.
Actually, external force is required, sir.
Ah, yes, external, yes. Why we are using the motor? Why we are using the motor?
Motor used to generate some mechanical energy to the required pump to reach certain RPM.
Yes, okay. Generally, is a motor is one application for driving force. Motor is a driving force. That is the application. Na?
Right.
Yes, sir. Driving
Pump
force.
application is a shifting the water from down to the top. That is the application. We know the application, everything. Motor, what is the application? And the pump also, what is the application? It's a generic. Why we are using here? It is a very important. Why we are using here?
There is a difference in height limit. For that, we required some machine to transfer that water from one source to the other source.
Yeah, this is a basic application. From today hours, we have to think about that different way.
Okay.
Yes, we are seeing the product means we are seeing the always product some application. This product this using, this product this using like this. But the application, it is not matter. What is the problem solving? That is a matter. What is the matter? Problem solving. The problem. What is the problem? Problem. What is my problem? I need water without any struggle. Whenever I open the tap, I need to come to water. That is my benefit. I have to solve this problem. Is it? Are you understand?
Yes, sir. Yes.
Yes. Always we are thinking about the application. This motor, this application, this motor, this. Rather than we have to think about the problem. How to problem? We have to solve the problem with our knowledge. You have the knowledge, and all the knowledge is the application. Clear? You know the motor means that is called some application. You can go any other industry, you can work. Motor industry, any compressor industry, you can work. That is a generic application. But what you do, solve the problem. Here is a solved problem. Not shifting the water is the application. But it is solving the personal problem, industry problem. Clear? Are you understand?
Yes, sir.
Yes, that okay. Here is I am using that. This is here. I need only 2 HP motor enough. 2 HP motor. Shifting the water. Suppose I am using the 5 HP. What will happen?
The water may
Power delivery. Power delivery means it's a power consume.
With the greater force, the water will be supplied.
Yes. We are going to solve the problem solving with the cost effective. Next one. Problem solving with the cost effective. What do you do? Problem solving with the cost effective. That is our duty. Energy auditor, what is our duty? Not go through all the book. We are going to solve the problem with the cost effective. This is a basic industry problem. What are the problem we are going to do? So suppose 1 HP, what will happen? 1 HP. 1 HP motor, 5 HP means water delivery.
Not sufficient power will come.
Yes, not sufficient. So without, what is the next one? without complement. Clear? Without complement, benefit. Without complement, benefit. Now you get it all the 3 points. More than solving the problem. Clear? You have to do these 3 things. Then only you will be the specialist in your field. In engineering, only we have discussed about the application only. You know about this? We are always know about the application. This is this application. This is this application. What type of problem solving? That is our duty. We have to find out. This calculation, everything simple. Anything simple. Everything simple. Clear? Okay. Now what? Here is a very important concept. Now this concept, understand why we are going to study the pumping system. Rajesh Modak, Vijay Panchal, are you understand why we are going to study the pumping system main?
Yes, sir.
Efficient
Yes.
selection and use of pumps.
Yes. With cost effective, without complement, problem solving. And yes, one more point also. Cost effective means almost comparing efficiency. Efficiency also. Here always include efficiency. Inbuilt efficiency. These are basic benefit everything. You have to understand. It's the imaginary part, but you have to understand. Then only you can easily study all the calculation. Calculation is the secondary part. Then what you do? You have to calculate how much power required, how to calculate efficiency, everything you have to do this one. Next concept, very important. This is a water tank. It's a top side tank available. Here is a pump available. Pump shifting water from top to bottom to top. Here to here. Here is a water available. This is water. This is a water. Okay. Here you have to understand head. Anyone is a head? Head means same like pressure. In compressor, we are using the pressure, na? Compressor. Here, water, we are always using head. Compressor, we are using air, always we are using pressure. Here, always we are using the pressure meter. In every meter have, na? Every equipment have some pressure for air or water, air, steam. Everything have pressure meter. Did you see any pressure meter in pipeline? Any pressure meter did you see? Any oil
Yes, sir.
pipeline,
Yes, sir.
water pipeline? You can see that pressure meter. It is measuring the how much pressure. That is recurring always kg per centimeter square. Kg per centimeter square. Here also available. Here also available. What is the pressure available? Everything checking. Pressure meter available. Here always you have to understand is a this water level to this water level. You are taking from your underground tank. This water level here. Top side tank water level without motor running. Very important. Without your motor not running now. This is called static head. This is called static head. If static head, if higher, lower, it's a difference. If static head, suppose your tank, underground tank is available your ground floor, okay? Your tank is available first floor and second floor and third floor. Okay, 3 tank available. Which static head very high? I will draw the diagram. Once you understand this concept, remaining everything easy. Here is one tank available. Here is one tank available. Here is one tank available. This is 1, 2, 3. Which static head very high? Very high, very low. For sample, I draw the diagram. Which static head very high? From here to.
3 is higher at side.
Yes,
and
3 is a
one
higher.
lower at.
Yes, static head. 3 higher than 2, 2 higher than 1. So, if static head very high, we need motor power high. Na? Are you understand? HP rating.
Required
So what
higher
will-
side. Yes.
Yes. So, what motor pump rating, HP rating also very higher. This simple concept. 3 greater than 2 greater than 1. Because here less force enough. Here greater than 2, greater than 1. Here greater than 3. So static head when increase, so you have to install the more HP power also increase. You see the power plant, raw water mill available 1 kilometer away. You have to shift the motor pump to deaerator something. Did you see any raw water mill, raw water in power plant? Long distance available, pump rating, pump house available. Did you went nearby any power plant or anything? Any cooling tower? Anyone not visit?
Yes, sir. I
Yes.
have already designed.
Yes. This is a basic concept. This is a basic
sir.
concept. What is a static head? The static head, which one is a higher, which one is a lower? So pump rating, which one you have to select higher, which one is selecting lower? We have to understand. This is a basic concept pump. Here, always you have to understand discharge head, suction head. Which one is a discharge head? Which one is a suction head? Any idea? Any idea which one is a discharge head?
Sir, discharge is the output of the pump and suction is the inlet of the pump.
Okay, exactly right. Correct. So we have to choose which one is the discharge head, which one is the suction head. So pump center line available na? Pump, the fixing. This is a center line. Clear? This is a center line. If you have the time, you can write it with me also. Center line. This is center line. Clear? This is called pump center line. They will ask sometime question like this. Pump center line. From pump center line to the pump center line to here is a HS suction head. Same pump center line to here is a discharge head. Water level. This is a discharge head. Clear? Now clear? Very important keynote. What is the keynote here? What is the keynote? What is the keynote? Pump center line. Which is the center line? Which is the center line? Pump center line. Any idea? Rajesh, Modak. Which is the center line? Vijay?
Sir, can you, sir, repeat this question again?
Yes, yes. Pump center line. This is a pump center line. Clear?
Correct,
This
sir.
is this is a pump center line. I draw the extra thick line. This is the pump center line. From here to here. You see, this is also I put it. Yes. Same. This is water level. So this is, I will draw no issue. This is a discharge head. From here to this is a suction head. Now clear?
Now clear, sir.
Now clear, na? So
Yes, sir.
the keynote always you have to understand. This is a pump center line. Which is a pump center line? Center point. Pump. This is a pump. Taking the water from down to top. This is a pump center line. So what is the total hit? Any idea? Total hit. Total static hit.
Sir, total had horizontal plus vertical pipeline.
Yes.
SD plus HS, I guess.
Yes. Now total static hit. HS plus HD, na?
Yes.
HS plus HD. This is clear now?
Right, sir. Yes.
Yes. This is clear, na? Total static hit. Pump center very important. And always check. Always check pump suction head. Top or down. This is a top or down. Pump suction head. Pump suction head from center line. From center line. From pump center line. Top side and down side. Are you understand this question? Pump suction head. Clear? This is a pump suction head. Top or down from pump center line. Now see the suction head from
Down.
pump center line down or top?
Down, down.
Down. Clear? Next you have to, I have to draw the top side. This is a pump. Everything you can draw, your note also knows you. Now, which is a pump center line? Which is a pump center line? This is a pump center line, na?
Sir.
Yes. This is a suction head, na?
Suction head, yes.
Yeah, this is a discharge head, na?
Yes.
So now you have to draw it, everything.
Sorry. This is what is this one? Any idea?
HS suction heads.
What is this?
HS.
Suction head. What is this?
HD discharge head.
Discharge head. Okay. Now tell me the total static head. Which is a total static head?
HD minus HS.
Yes. How to draw it? This one? From here to you take it. This is a point.
So if discharge head is above the center line, we need to subtract from the suction head.
Ah, yes, exactly.
So it is below the line means we need to add.
Add, yes. Now this is total static head. Static head. I will write it here. Below suction head. Below suction head. This is above suction head. Okay, now
So-
total static head equal to
HD minus HS.
total static head equal to HD minus HS. HD always higher. Okay, higher minus lower. Clear? If minus coming, don't put it minus. Always, sometime you are mismatching. Sometime you have changing na value. So sometime is coming minus. Don't put it the minus. You have to check it. HD minus HS. Higher minus lower. Now point is clear. Now point is clear na? Clear everything?
Yes, sir. Clear.
Yes. Okay. Now is a pump is available. Okay. Now pump connected with the motor. Na? Now concept everything clear. Below suction head, above suction head, everything clear. Above suction head, below suction head, everything clear. This also you have to note it. This is our learning. This 3 point you have to learn yourself. I will highlight separately this one. Okay. Okay, next point. This is diagram. Just see that this one. Now you can see the visually. This is a pump. This is a motor. This is a motor. This is a pump. It's a tank. This is a tank, na? This is suction. Here downside. This is what type? Suction get below or top side?
Above.
Above the
Below.
center line.
Yes, below. This is a suction head.
is
Yes, this is a suction
below
head.
the center head.
Yes, below the center
Center
line.
line.
This is a center line. Below the center line. Below the center line. Suction head. So now what we do? Same, you know the below suction head means total static head. What is the formula? HD minus plus HS. Clear. Finish. So static discharge head from center line to this water level. Okay, suction head here to this water level. Then both include. Now clear na point? This is a motor without running. Suppose motor running means what will happen? Motor running means what will happen?
Pump also will run and
Yes, pump run.
will flow.
Water is going to flow from top to bottom, bottom to top going on water. Then water, if flowing means some friction always available, na? Friction.
Yes,
If
sir.
yes, 2 HP pump means exactly not operating 2 HP. Something friction loss, something available. That is also included now. So friction, that is called friction loss. Clear? This is a motor off condition. We are checking. This is a motor. Simply you can say motor off. Motor off, no running. That is you are checking water level. This is a static hit. Now motor run means what will happen? Pump running. So it will take the water from downside to shifting the top side. So something friction head increase. Friction head means then water when start with the flow, pressure increase. Clear? Something actually system designing is a 10 kg per centimeter square. 10 kg per centimeter. Suppose the friction gets everything increase means what will happen? Pressure increase. That is called hit. 11 kg per centimeter square. Due to what is the main problem? The fitting. What is the main problem? Friction. The piping, fitting, here everything. All the mechanical equipment, it is creating system resistance. Are you understand this? What is this? Any doubt? Simple, you are not moving your vehicle. Just you start the vehicle. Exactly. If you are moving, you are start with vehicle, just moving, what will happen? Your vehicle tire with road, some erection happen, friction. Modak, Vijay Panchal?
Yes.
Yes, you are
Yes.
just start with vehicle.
Yes, sir.
Once start with moving, what will happen? It will not give the 100% result. It will not give 100% efficiency. Some friction is available. Same, that is a mechanical friction. This is called mechanical friction. Na? This friction, what will happen? This is a downside mechanical friction hit. It's a top side mechanical friction. Once fluid running, what will happen? Once fluid run, what will happen? Here pressure increase, flow increase, then velocity increase in water. Always remember, any pipeline, water or air flowing, how to air flow? What we say? Air flowing, what unit we are saying? Velocity, na? Moving the velocity.
Yes.
Yes, it's moving velocity. Then we are getting quantity. Finally, how much quantity? Same, your vehicle moving, the speed is very important. Na? How much speed going on? Your vehicle, your two-wheeler. 80 km per hour, 20 km per hour. Same concept. Water flowing is how much velocity? Meter per second. How much? Are you understand this one? This concept? Same vehicle moving 10 km per hour, 20 km per hour. Same concept. Velocity. Water moving means some velocity. So meter per second. That is called totally we are taking is a dynamic head. Dynamic head. Are you understand what is a dynamic head? What is a dynamic head? Any idea? Dynamic, static. What is the difference? Dynamic, static. Still now we are discussed with motor off condition. Now we say on condition. So on condition always remember. What is always we have to remember? On condition, motor on condition. Your vehicle on, you are owning the motor, you two-wheeler just running, what will happen? Creating momentum. Any idea? On condition, motor on condition, creating momentum. So it is creating friction loss. Friction loss, that called friction head. Clear? Any doubt? Now understand what is the friction head, friction loss? Friction loss, same friction head. There is no difference. So friction head friction head, friction loss directly proportional to very important 1 mark. Directly proportional to flow square. Clear? Any doubt? Flow square. Rajesh, Modak?
Yes, sir.
Yes.
Yes, sir.
Yes. Some question, what they asking now, they are giving some friction head. Normally they will ask only the static head. Sometimes they are giving the friction head. Motor on condition. The calculation 2 types available. Calculation 2 types available. What is the 2 types? One is a motor off. Another one is a motor on. Motor on. How to find motor on, motor off condition? Any idea how to find motor on, motor off condition?
If RPM is 0, motor will be in off condition.
But yes, but they will not give like this. If they give the friction head, dynamic head, that is called motor, it is a running condition. They are giving the data in motor running condition.
Okay.
If not given any friction gate, they will give you only the static gate, discharge gate, suction gate means that is motor off condition. Always this very important. Key note always remember. Always remember note. What is a note? If HD, HS given only, that is motor off. Second, if HD given, HS given, dynamic hit or friction hit. Dynamic or friction. Given, then motor on. Clear? Motor on condition. Just remember this one. No worry about it. While calculation time, you can easily understand quickly. Now clear the point is motor on, motor off. Still now you have completed motor on, motor off condition. Okay. What is the formula for motor off condition? Total static hit for below the static hit. Tell me quickly.
HD plus HS, no?
Yes, okay. Above the static hit,
HD minus
suction
H.
get HD minus HS. Okay. Next, motor on condition. What is the formula? Simply. Very important.
Dynamic head also we need to include, right?
Yes, that is okay. That is called, sometimes they ask total difference gate. Total differential heat. Total differential or sometimes total heat equal to HD plus HS plus percentage of flow. Percentage of flow square dynamic head. Clear? Or friction head. Dynamic or friction head. This is for this formula for
Motor on condition.
motor on condition. Another one, suction head downside. You can keep it.
Yeah.
Plus or minus, very important. Plus or minus is a generic formula. Plus or minus. Plus or minus. Plus means
Below the center line.
yes, below. Minus
Above the center line.
above. Here is a dynamic head or dynamic head. This is a dynamic head or friction head. This is a very important. Why? Friction loss directly proportional to flow square. Na? This is why we are using percentage of flow square. Simple. Multiplication of dynamic head. You can get it all the head clearly. It's a simple formula. Okay, Rajesh, Modak, Vijay Panchal, understand this formula?
Yes, sir. Yes, sir. Clear.
Yes. Now clear the point?
Yes, sir.
Yes, pump, everything clear. Okay, we have some assignment.
Yes.
What
Sir.
is the assignment? Your application. You know that your application means your knowledge. You have to write it your knowledge. How can solve your problem? What are the problem available? Are you write it your what are the problem you can solve? This is we have to do this. This is very important. Why? Because we are assigned for specific problem solving skill. Clear? So you have to understand your knowledge. You know the more knowledge, na?
You mean to say that related to this pump and
Yes.
systems only we need to identify
No.
the problem and this one, sir?
Yes, yes. This is assignment for yourself only. Whatever the knowledge, you can write it. You can write it your knowledge, and you have to write it your problem solving skill. You can solve which problem you can solve. Which problem? Are you understand, Modak? Vijay Panchal, Rajesh?
Suppose I meant to say if my pump is not giving the proper suction head or delivery head, that is my problem. So
Yes.
what kind of best solution I can give?
Yes.
That might be
That
I have to write.
That also you can write it. Otherwise, you have some knowledge in compressor. How can solve it? Solution. That is a high impact creating solution. That is a problem is a high problem compressor. High problem is a pump. High problem is a DG set. Whatever the you have knowledge, you have the more number of knowledge available. That is a application. This application, how to solve the problem. Suppose
Okay, sir. Understood.
yes, understood. I got a certification, energy audit certification. I'm solving your problem, commitment, some commitment. I am created a commitment, simplification. So can you tell me what problem I'm solving exactly? I'm solving what problem exactly for you, Rajesh?
I'm unable to get that certification. So you are
Okay.
supporting us in a practical solutions, giving the practical solutions and how to practice that. So
How
that
to practice in depth level, accountability, I guide you.
Yeah.
And simplification the concept. That is also I'm solving the problem.
Right, sir.
Yes.
So one we can say now, suppose if in industry IE2 motor is using, so that is giving less efficiency. So if I
Yes.
propose it has to be changed by IE3 or IE4 or IE5, so that kind of thing we can write now, sir.
Yes, that kind of you can write.
Okay.
Once you write it, you can understand. Okay, I have the potential to solve this problem.
Okay.
If any industry, Modak, what kind of problem I'm solving you, Modak Priya?
Yes, sir.
What kind of problem I'm solving you?
Sir. Hello.
Hello, can you hear my voice?
Yes, sir. Please, sir. Repeat again, sir.
Yes, exactly what kind of problem I am solving you?
Sir, you have resolved many basic idea regarding the pump, and on the basis of your concept, we can resolve some numerical, and it is very helpful in the practical life also in engineering line.
Exactly. Basic concept I explaining with the diagram. I'm asking the question, some question, what are the possibility, we have discussing. Then
Yes,
you
sir.
can understand, okay, this class is a regular, is a comfortable for you. We are making comfortable. Same, I have some application, I am utilizing this solving your problem. Same, you have some application, means some knowledge. So how to utilize your knowledge to solve the specific problem? You have to write it. Then you can shortlist maximum main 6 problem.
Yes,
main
sir.
6 problem. Then you can understand.
Correct, sir.
Yes. This is extracurricular activity. You have to do it. It's very useful for you because we are energy auditor now. So we have to solve the problem. It's a main concept for. We are not telling about this is application. Not like that. We are not saying for the application. We are here for to solve the problem, specific problem.
Yes, sir.
Exactly. Okay, Vijay Panchal. Can you hear my voice, Vijay Panchal? Okay, Rajesh. Rajesh, Modak, up to now, concept clear? All the concept?
Yes, sir.
Yes, sir. Clear, sir.
Okay.
Sir,
Okay.
sir, please tell one more what is the dynamic pressure?
Yes, I will. Next class, I will explain.
Okay, sir. No issue.
Simple. Dynamic pressure means once motor running, that is creating momentum, that creating dynamic.
Okay.
Understand? This dynamic means static means it's a static hit without fluid moving, without moving the fluid from bottom to top. Once you motor run, what will happen? It creating momentum, that creating the pressure, that is a dynamic.
So, sir, the dynamic pressure always greater than to static pressure or what?
It's a dynamic pressure is something movement, friction head like this. Both include
Only-
finally yes.
Yeah, only friction.
Yes, friction head. You see the diagram? Can you see the diagram? This one. Here is a static head available. Here is a friction head.
Yes, sir.
This is a dynamic head.
Okay.
One is this is a mechanically friction, some friction available. This is a velocity head. So depend upon the static head. Some applications have a small static head and maximum variation head. Small static head, dynamic head very big. Are you understand?
Yes, sir.
Yes, we will see the diagram next class. Tomorrow class we will see that everything.
Okay, sir.
Okay, Modak. Okay, Raj. Thank you very much. Bye.
Thank you, sir.
Okay, bye.